Hi, my name is Dylan. I'm an undergrad at the University of Hawaii at Manoa, and I've had the pleasure of working in Dr. Joyner's lab for the past 2 summers. Here at Sloan-Kettering, the Joyner lab typically works on cerebellum development, but instead, Alberto and I are working on how bones are able to grow symmetrically. How are they sharing information with each other so that they know that they need to either increase growth so that they match the other, or decrease growth. And the reason we're looking at this is because the symmetry of our body is so important in our everyday lives. It allows us to bike, to run, to walk, to play instruments, and without this, all those seemingly easy tasks end up becoming pretty difficult. And we're going about this by looking at different ways that they could communicate. So one way is through the sympathetic nervous system, which it's been found that those sympathetic nerves are actually within the bone and are important for bone remodeling if they get injured. So it makes sense that if these nerves are already within the bone, then they should, or they can, be an integral part for their communication. So we're looking at different pathways, and we're measuring the usual inconsistencies in development and whether those inconsistencies decrease or increase during a certain spot in the developmental timeline. And we're doing this by staining the bones with 2 stains, one that dyes cartilage and the other that dyes bone. And we can take those and we scan them, and then it remodels them into a 3D program, and with that 3D program we can actually measure just how long the limbs are. And that gives us a pretty standard, okay, at this point they are usually within this range. And we can go further with that using that kind of idea by altering different areas of the sympathetic nervous system and seeing whether or not this actually affects the symmetry between the 2 bones. And we basically follow the same kind of paths. We see if we block the sympathetic nervous system, do the asymmetries increase? So that's just one aspect. The other aspect is just looking at, okay, what are the possible pathways, and do they even exist within the growth plate, which is the area that most of the growth within the bone occurs. And we've been looking at adrenergic signaling, as well as by now this immuno that you see here is a stain for phospho-ERK, which is usually related to increases in cell proliferation. And you can see here in green that whatever chemical that we've added into the mouse's diet is actually causing these cells to proliferate at a higher rate. And actually, when we measured these bones, they were different sizes. We're headed into a good direction so far. I choose development program through an old mentor, and he suggested I should apply for it. So I applied. I fortunately got in, and they gave me a list of possible mentors, a list of 5. And I think the thing that stood out was just that it was a project that I hadn't really considered doing before. I never really thought about the symmetry within the bone. I mean, it was fascinating, and I wanted to be a part of it. So I contacted them and told them I'd like to work in the Joyner lab, and everything kind of worked out. And both Dr. Joyner and the people spearheading the Choose Development program got me into this summer program here last year, and it was a nice mix of students coming from different backgrounds, all with an interest in what they were doing. And I got to meet a bunch of undergrads, attend several talks from a wide variety of speakers here at the institution. And I'm part of that program again, and it's opened up a lot of opportunities, and I'm excited that I have been able to be a part of it. And I am grateful that I got into the summer program, and grateful for Alberto and Dr. Joyner for actually accepting me. And I think it was one of the better decisions I've made in my undergraduate career.